Question 29. Given that f of x equals x squared minus 1 and g of x equals the square root of x plus 1, sketch the graph of y equals f of g of x and state its domain. So this is a composite function. So as with any composite function, it's important that you know the range of f is determined by the domain of g, because g is on the inside. So how does that apply? Well, we are asked to state the domain of the composite function. So when we're stating the domain of the composite function, we really want to look and concentrate on the domain of g of x, because that domain will carry through and be the domain of f of g of x. So let's look at the domain of g of x. So if we look at the square root function, we know we cannot square root a negative number. So when we're considering the domain, I'll do a quick expression here. X plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to minus 1. So when it comes to this problem, that is our domain. So we could actually fill that in now, and we want to make sure we say that. We don't forget that. And then, of course, we'll just say x is keeping it real here. All right, so now let's do this composite function. Find the equation for this composite function. So if y equals f of g of x, another way of saying g of x is to say square root of x plus 1. So if we're finding f of the square root of x plus 1, where we see x in the f equation, we replace that with the square root of x plus 1. So how can we write our new equation? It is y equals, so we're going to substitute in square root of x plus 1. But what do we have to do? We still have to square that function and subtract 1. So this is actually where we could see the restriction, right? Even so, this still has the restriction that x has to be greater than or equal to negative 1. But anyway, so let's expand this. And so the square root times the square root goes away. So we're going to get y equals x plus 1. That's the squared part, but we have a minus 1. Now, as soon as we say that, we want to remind ourselves of the restriction. This is only true if x is greater than negative 1. So we should state that restriction when we go from this line to this line, just to remind ourselves of that. Obviously, we could simplify this, and we just get y equals x. We still have that restriction. X is greater than or equal to negative 1. So if I were to guess, students who lost marked on this question just graphed y equals x, and they forgot about this domain restriction right here. I like this question. A little bit on the tricky side, but it makes sense. So graphing y equals x is really easy to do, so we won't even do a table of values for that one. Now remember, we're starting at minus 1. So if x is minus 1, y is minus 1. If x is 0, y is 0. If x is 1, y is 1. So we can see what the straight line looks like. Right, it goes up at a 45-degree angle and continues to increase. So we're starting it at minus 1, and we're continuing on. I'm getting better with my graphs. Oops, as I say that, I mess up. But I'm getting better with my graphs, but do not go beyond that. Okay? So you could also write the equation next to the graph y equals x with x greater than or equal to -1.